Hey everyone, just wanted to talk about a charging system problem that's pretty common on these Vulcan 750s. So the problem is typically either with the stator or the regulator rectifier. My particular problem presented as the charging system still outputting above 13 volts or so, but it did not end up charging the battery, and it would slowly discharge as I would ride for a few hours at a time. And every time I would come back, the voltage in the battery at the two terminals at the top would have dropped by 0.3, 0.4 volts, all the way down to where it would get to 12.1, 12, and the bike would start running very roughly, and then it would not start or backfire when it was starting. So my problem in particular is that because I had a loose ground, it appeared that my regulator rectifier, which sits below the battery under the junction box, had overheated, and that caused it to go bad and no longer output any voltage. So the first thing I did was replace that. They're relatively cheap. You can get one for probably $20, $30 on eBay. And that did end up bringing back voltage to the battery. However, again, brought it to that 13 and a half volt level, and without enough current to actually charge the battery. So then that led me to the stator, which is a much larger job to replace because of the design. And the way that you check the stator is you check the resistance between the three yellow leads that come from the stator, which are down there. They go right under next to the output shaft, and they'll run under the engine. And then they're in this little black wire, which ends up coming out into these three wires and then goes to the stator. So the way you check those is you run your multimeter leads to each of the three output wires, and then you check the resistance between them all. I believe they should all be 0.34 to 0.52 ohms. And then from there, you'll want to make sure that the leads going to the stator are not grounded. So what you'll do is you'll use the same ohm setting on your multimeter, and then you'll put one of the leads into each of those wires and then try and touch a ground on the engine. The easiest place to touch ground would be your negative side of your battery. Also, any exposed metal that is on the bike will also work. And there should be no continuity there. Your multimeter should read infinite. If you're using a continuity light, it should not turn on. And if it does turn on, like it does in my case, then that means that your stator is internally shorted and you have a bad stator and you'll need to replace it. So because of the design of these bikes, replacing the stator is not exactly as straightforward as going out and buying the part and simply slapping it in and wiring it in. For whatever reason, Kawasaki decided to make a removable stator cover plate. However, you would actually have to take off the entire side of this case all the way around and then remove the entire side case in order for you to access the stator from the other side. The way it normally looks is there's this plate in the middle, and then you can see part of the stator through this little window right here. However, the easiest way to go about replacing your stator is to take the stator plate off and then drill a hole out so that you can get the stator out without taking the entire side cover off. Because again, the side cover would require you either lifting the engine up or cutting the frame out, or for me, the easiest way to go about replacing the stator would be to cut out the side to get access directly to the stator. What you'll need is a hole saw. Some people have done it with a Dremel tool. Some people have done it with a pencil drill. I wanted mine to be relatively concentric, so I ended up picking a hole saw. This is a DeWalt. The arbor, I think, was $13, and the hole saw itself was about $23. This is a 4 1/4 inch hole saw. I do believe that I've read that you can do it with a 4 1/8. What you'll need to do is when you open your side cover, you'll first want to take your hole saw without the hole saw attached. You'll want to begin drilling a small indent into this bolt in order to keep your hole saw centered. That is the hardest part about using a hole saw, is keeping it centered and having it not rip the drill away from you. The way I went about it is I removed the hole saw part and just used the internal pilot bit. I center punched a few times into this bolt and then slowly drilled out a little bit of this bolt to give the pilot bit somewhere to bite onto. Then from there, you'll want to put your hole saw back on, and then you'll want to slowly run the hole saw on top of these ribs so that it will mark out where it's going to be cutting. Again, because we don't have a very deep hole, this is going to likely want to make your hole saw grip one of these ribs and then rip away from you and go off center. I actually ended up, unfortunately, bending the pilot bit because of the amount of torque. The goal, once you drill this initial hole and put your hole saw back on, is to simply make small scratches and mark up the ribs so that you know where to cut. So then once you've made a mark with your hole saw, take some type of small grinder. In my case, I have a 4-inch air grinder. You'll want to notch these little ribs out where your hole saw was trying to cut. And you'll want to notch it down until it gets level with this base plate. It'll give your hole saw a way to sit flat against the surface that you're cutting. From there, you can remove the pilot bit, and then you'll want to turn your drill into reverse and then have your hole saw just run backwards on the hole so that it begins making a very light groove. The main problem with all of this is the hole saw will want to take deep bites out of the aluminum, and you're trying to get as flat of a surface as possible without having the benefit of the pilot bit centering the entire thing. So run your hole saw in reverse for a while, make a solid groove until the hole saw has a small groove for you to equally apply pressure. From there, you should be able to take your hole saw and then flip your drill and then actually spin it the way so that it actually cuts. That will probably take maybe 20 minutes for you to actually make it all the way through. It will probably take you a little bit, so go nice and smooth, be careful. So once you have that out, if you had already cut your stator wires to get them out of the way, your stator should be right behind this plate. And this plate will be attached with 3 Allen head bolts. And then this plate and the stator should just fall out. So from there, you'll probably have a lot of aluminum chips laying around everywhere. The preferred way to get rid of these is to wash it out with kerosene. Now, the kerosene flush was the part that I was most concerned about, but it ended up being relatively straightforward. So once you have the side drilled out, you're going to end up with a bunch of metal shavings all around and all inside. So in order to flush it with kerosene, first thing you'll have to do is take out the drain plug right there and then pull out the spring washer and filter. So from there, once you get all the oil out and get it all cleaned up, you're going to want to do multiple flushes. So it's best to get the oil out and cleaned up before you move on to the kerosene flush. So from there, you're going to want to grab some type of kerosene can that pours freely, or you'll want to grab some type of glass bottle. You'll want to pour the kerosene in there. Basically, all you have to do is just dump a bunch of kerosene in the side where you did the drilling. So the places that I dumped it were in these 2 channels all along the side. You can splash it in there, and then you'll also want to pour it into the fill cap. It will all run out of that hole into an oil pan, and you can see from all the sparkles at the bottom, that's all of the aluminum shavings that I had from the drilling process. I'm just going to take the kerosene and filter it out with either a cloth or paper towel or something, and put it into a funnel, put it back into the bottle and run the flush a few more times. And then once I'm done with that, I will take the bike off the center stand and lean it back over and just let it air out and get all of the kerosene out into a final drain of all the kerosene. And from there, you should have all of your metal shavings out, and you should be good to start reassembly. So once you have the kerosene rinse done, the next thing you want to do is put the stator back in. But because we cut out the side of the side case that holds the stator in place, then we need another plate to hold it directly where it would have otherwise been held by the complete side case. So the first thing you'll need is the stator plate mod from GC Extreme, and it comes with a set of hardware, the plate itself, and what this plate does is it holds the piece that you cut out, which will be bolted to your stator, and it holds the piece that you cut out directly in the same position as where it would have been if the case was still one piece. So that way it's held in place from the outside so that you can still easily remove all of this without having to take the side cover off. So the way that this works is that the plate that you cut out will go onto your stator. You'll have the 3 bolts coming in from the other side, and then you'll take this plate and you'll bolt this outer plate to the plate that you cut out, which holds the stator as well, and then these 3 outside bolts bolt to the stator cover plate that hold it directly in the middle of where it originally was. So while trying to assemble the stator to this cutout plate, I ended up running into a bit of a snag. This screw right here was actually interfering with the side of the centering ring, so I ended up having to grind out part of it so that it would fit. Also, I realized that the centering ring needed to be cleaned up a little bit, so I took some 220 grit sandpaper and some Scotch-Brite to sand this down a little bit to clean it up before reassembling it. Otherwise, it was incredibly tight and would have made removing this later on a nightmare. One other thing I noticed is that these bolts that came provided with this plate do not reach all the way through if this plate isn't all the way mated, and rather than hammering it in, you can use the original bolts, which are a little bit longer, to work the plate in to fit snugly against the new stator before taking these out and replacing them with the actual bolts with some Loctite. So once you're done assembling the stator plate to the new stator, you're going to end up needing to modify the stator cover because these button head bolts actually interfere with some of these ribs, so you'll need to grind them out. So I actually only ended up needing to cut out this one small notch for this bottom button head bolt in order for it to sit flatly. From there, if you line up all the bolts and it makes contact and doesn't rock back and forth in any direction, then it's sitting flat and you should be good to go. The next step would be to find some way to route your 3 new stator wires. So the route I'm going to go is by cutting a small lip and the stator cover for them to head out of. The other way that some people do it is they attempt to either solder or find some way to pull the lines through the original stator wires out through this boot. Mine are pretty old and crusty, and that would be very difficult. It'll also probably be a little bit easier to replace the stator at a later times if I don't have to continually reroute these. So I ended up taking my same 4-inch grinder and cutting a small channel for the stator wires to run through. I hope that when this has pressure applied to it, that this will flatten out and make a seal with this rubbery coating on the wires. But otherwise, I can just use some silicone gasket maker to seal it up. So before putting in the stator on the new stator plate, you're going to want to put in these 3 studs, and that will help line up the stator as you insert it, because otherwise it'll want to get sucked in and attract to this magnetized wheel. So you will put in these 3 studs, put in the stator plate along with the stator, and then one by one, when you put your cover on, you'll replace each of these studs with a bolt. Also, before final assembly, you'll want to make sure that you take your ignition pickups and screw them back in. So a couple of things, I ended up having to grind out this channel a little bit more for the stator wire to fit through correctly, and also I ended up grinding some of these ribs out so that the wires for the pickup don't interfere. But it seems as if no matter any amount of grinding, that once you put it on and apply pressure, you still have a small gap all the way around. So it appears that I'm going to need to use at least some RTV silicone in order to seal this up. So after putting the plate back on, it actually turned out a little better than expected. The notch that I ended up cutting out, I just wrapped with a little bit of extra RTV and kind of shoved it down in the hole. And in order to route the wires back under where they originally were, all you need to do is let them dangle down. Just run them behind this linkage, then run it through this little channel, and then you should be able to pull them through from the other side. Then they should end up where the original wires were. This actually ended up turning out pretty well. Most of the RTV spread out when it cinched down, so I should have a good seal. So I'll let that dry, let the Loctite dry on the stator plate, and afterward I should just be able to hook up the bullet connectors and it should be good to go. So after putting the oil back in and letting the RTV dry, I have my multimeter hooked up to the bottom outside plugs to the regulator rectifier. So that should give me the output voltage of the regulator rectifier. With the ignition on, I have about 12.2 volts. So we're hoping to see anywhere between 13.5 to 14.5 with some RPM. This is still with the ignition on, and it'll slowly settle back down. But otherwise, looks like the replacement went well. Thanks for watching.